Hello everyone, hope you're doing well and welcome back to my channel. Today we are at day 19 of the November Daily Code Challenge and we again have a medium question in front of us, and this is again to do with arrays, and to be more specific it is related to the sliding window approach. Okay, let's quickly see the question. It's really interesting question. If you are a beginner you can definitely try it out because it's really good. Okay, even if you are a beginner, this will test whether you are able to imagine the things correctly or not, and if you are aware of what a sliding window is, then this is a really nice question to test whether your understanding is correct or not for the topic. Okay, so let us begin this question. It is 2461 maximum sum of distinct subarrays with length k. Okay, so let us see the input first. First input is the integer array given to us. K is again going to be, let me tell you in the starting itself, this is going to be the length of the subarray. Okay, for which we need, this is the maximum length that we have. That is in our window, in our sliding window, we can have at max 3 elements only. Beyond that, we cannot have. Okay, that is the basic idea. So let us see the question they have given. Okay, so you're given an integer array nums and integer k. Find the maximum subarray sum of all the subarrays of nums that meet the following condition. Okay, see, they are saying find the maximum subarray sum. Okay, first of all you have to take subarrays and among them you have to find the sums. Whichever is the maximum, that is going to be the answer. Okay, as simple as that. Find the maximum subarray sum of all the subarrays of nums that meet the following conditions. Okay, they are specifying two conditions. What are they? The length of the subarray is k. Okay, that is only when the subarray is of length k you have to take the sum, and among all such sums you have to take the maximum sum. Okay, that is going to be the answer. Next, all the elements of the subarray are distinct. Okay, so we'll see the example one. After that you will be very clear what this means. The idea here is whenever you're taking subarray, it should be first of all of length k. Next thing is, inside that subarray it should not have any repeating elements. If it is repeating, then we cannot consider the sum of that. Okay, we have to simply ignore that subarray. We have to go to the next subarray and so on. Okay, so similarly, so see, the idea is very simple. If you are trying to do in brute force approach, what you have to do, see, keep it, go through all the subarrays of length k. Okay, as simple as that. Go through all the subarrays of length k. Among them, whichever subarray has distinct elements, get its sum. Okay, and at last you will have to return among all such sums which is the maximum sum. Okay, that is the question. Okay, return the maximum subarray sum of all the subarrays that meet the condition. If no subarray meets the condition, return zero. Okay, this is again going to be edge case, but here the best thing is they are not asking us to return -1. Okay, zero is very much you know uh, I can say like neat in this case, because zero means like subarray sum is zero, right? If they say -1, you have to keep a separate else if condition for this. Okay, so but in this case that is not needed. So they are giving the definition of a subarray. That is fine. Let us quickly jump to the question and answer what is happening. Okay, so this is going to the example one. So here they're saying k is equal to 3. That is, we'll have to go through all the subarrays which for which k is equal to 3. After we go to a subarray, what we have to do? We have to determine whether there are non-repeating elements or not. That is, whether all the elements are unique or not. Okay, if all the elements are unique, get it sum. Similarly, can keep getting the sum of all such subarrays. At last, we have to find the maximum among all the sums. Okay, so let us see the example one. So case three, that means I will take in a group of three. Okay, one first group is 154. Okay, second group is 542. Okay, similarly, so see, like that we have to keep going. Okay, 154. Okay, what is the sum? The sum is going to be 10. Okay, they have mentioned it clearly. Okay, 154, the sum is 10. Next is what? 542. Okay, then the next subarray of length 3 is 542. So what is the sum of this? Sum is 11. Okay, then the next 4, 2 and 9. What is the sum of this? 4 to 9, the sum is 15. Okay, similarly, like see, we have to record these sums like this 10, 11, 15. We have to keep recording these sums. At last we have to return the maximum sum. Okay, so we did till here 4 to 9. Okay, what is the next one? 299. Here the elements are repeating, so this subarray is not valid. Okay, 299 is not a valid one. Okay, so we have to go for the next. So remove 2, it will have only 999. Okay, 999 again is it not a valid one. Okay, and after 999 we will not have a subarray of length k. So again that is going to be the last subarray that we will have for our consideration. Okay, after 999 we have to stop, as simple as that. Okay, so if you try the brute force approach, it will take you around O n square to get the subarray itself, and then to check whether all of the elements are unique or not, we'll again need some more you know uh, some processing. Okay, so I can say like for each subarray again you will need around O n time to understand whether anything is repeating or not. So that is really going to be a very costly approach. And if you see the constraint of this question, okay, it is going to be around 10 power 5. So you cannot afford to have a solution which is more than n log n in this case. Okay, for this time complexity, you cannot have a solution which is more than n log n. Okay, so we'll quickly see approach which makes it possible to have solve in O of n. Okay, we'll try to solve it in O of n. So yeah, let me start my approach. First of all, I will show you the dry run and then we'll go for the code. Okay, so this is going to the first example. Okay, this is going to the nums array and we are given k equal to 2. Okay, I will use two success. Okay, one is the window, that is the window that I'm going to move. That is I'm trying to show the sliding window approach. Okay, and next is the maximum subarray sum. Okay, this is going to be our answer, and here the subarray sum should be of a subarray whose length is k. Okay, as simple as that. Okay, just to mention that. So okay, let me write it len k so that you understand. Okay, len underscore k, maybe that is the better way to write it. Okay, first I will take 1. Okay, see, one by one I will take all the elements. Okay, 1. Okay, fine. Take the next element 5. I will check before inserting 5. I will check whether 5 is already there or not. It's not there, so I will insert 5. Okay. So please pay attention to my words. This is going to be the dry run of the algorithm. If you can understand by the verbal explanation itself, then you can pause the video and start the code. Okay. If you're not able to do it, then only continue and see the code. Okay. As simple as that. So see, yeah. First of all, I got the 1 because it was empty. So 1 is not already existing in the window. I got 1. Next 5. 5 already doesn't exist, so I will get 5. Next, I will check for 4. Whether 4 already exists my array? No, it is not already existing, so I will get 4 again. So fine. Next, now my subarray, this particular window is of length 3. So I will have to take the sum of this. What is the sum of this? It is going to be 10. Okay, see, it is going to be 10. Okay, initially this will be 0. Okay, so I will compare whether 0 is bigger or 10 is bigger. 10 is bigger, so I will replace this with 10. Okay, as simple as that. Fine. So since I do not have a space for a new element, now what I will do, I will have to remove the first element, that is this particular element from the left. Okay, I will have to remove this element now. So now it is 5 and 4. Okay, so we'll go to the next element. What is the next element? Next element is 2. I will check whether 2 already exists in this or not. No, 2 it not already present. Okay, 2 is not present already, so I will include this also. Fine. Again, I have reached a length of k, that is my window is now of length k. What I have to do, again I have to take the sum. What is the sum of this? It is 5. Okay, 6 plus 5, which is 11. Okay, I will check whether 10 is bigger or 11 is bigger. So definitely 11 is bigger, so I will get 11. Okay, then again, I do not have space for a new element. What I will do, I will pop the first element out. Okay, that is the one which is towards the left. Okay, now I will have 4 into. Now I will check for 9 whether 9 is already there or not. 9 is not there, so I can include 9 also. I will include 9. Again, same thing. Now it is of length 3. So what I will do, again I will take the sum of this. What is the sum of this? Okay, which is going to be 9 plus 2, which is 11 plus 4, 15. Okay, so I will check whether 11 is bigger or 15 is bigger. So definitely 15 is bigger, so I will replace this with 15. Okay, again, like I don't have space for new element, what I have to do, I will have to replace the, that is remove the very element over the left. Okay, 4 is removed. Fine. I have done till this point. Okay, 2 and 9 are also done. So till now I have done till this point. Okay, now comes the second last element, which is 9. So I will now try to have the 9. Okay, now when I am trying to insert 9, I got to know that no, 9 already exists. Okay, so the idea here is, if I include 9, it will not be a valid subarray for me to consider. Okay, so what I have to do is I cannot consider it. So what I will do, I will remove everything. So see, 9 is present currently in this position, right? So what I will do, till that position, I will remove everything present in my window. Okay. So the idea here is, let us say after 9, some more elements are there. So what I will do, okay, here is 9, and let us say some more elements are there. So I will remove till 9 everything. Okay. Till 9, I will remove everything. Okay. So I will remove 2 first. Okay. First of all, 2 is removed. Then 9 is removed. Okay. Fine, 9 is also removed, and finally now I can insert this particular 9. So I will insert this 9 now. Okay, that is going to be the idea, right? So that is going to be the idea. Fine. Now what happens? Now another 9 comes. So again, already 9 is there. So what I have to do? I have to remove this 9 first. Okay. So see, let us say like this. Okay, just to understand, because in this example it's very limited. Okay, but I want to get the understanding of every possibility. Okay, so let us say 9 is like this. Okay, it is in middle of some more elements. So what I have to do? I have to remove all the elements which are appearing before 9 and till 9. Okay, so till 9 I will remove everything. Okay, then I will insert the last 9. Okay, this is the particular 9. Okay, and then the loop will get over. Okay, here at this point the loop is over, but since in this case there is only one element left, so this will not be of length 3, so I cannot consider the sum of this. Okay, so this is where I will end. Okay, so if you see, the maximum length that we are having is 15, so we have written 15 as the answer. If you see, this is going to be a tracing of example 1. Now we will try to understand the same thing using our code. Okay, in the code I have included multiple comments, so that you will understand everything what is happening there. Okay, so let us see the same here. Let me zoom out a bit so that I can capture a maximum output here. Okay, yeah. So we are doing the same thing. Okay, let us keep both things side by side. So this is going to be the first example, and I'm going to show you the tracing for that. Okay, case 3 here. So first, what will happen? So see, just compare this and this. Okay, this is the real question, this is the output of that. Okay, so what happens first? The element will be introduced. Okay, element 1 is introduced. What is begin? That is the, what is my window starting and ending. Okay, so my window starts at index 0, my window ends at index 1. Okay, and this is I'm going to maintain. For example, see, this I'm going to use a map. What is the map going to do? For every element, okay, it will track at which position it is present in my window. Okay, so that is like when my window is over some elements, right? So if an element is there in my window, what is the position at which it appears? Okay, so initially if you see 1 is at index 0. Okay, in this 1 is at index 0, so I will write 1, and the key for that will be 0. Okay, as simple as that. Next 5 comes. I will check whether 5 is already there in my window or not. No, it is not there in my window. How I am checking? I am going to check in this particular dictionary. Okay, as simple as that. In Python we call it as a mapping or a dictionary, whichever we call it. Okay, so it is not there in my dictionary, so I will include this also. Now the end of my window will be increased. Okay, begin will still remain the same. Now in this you see I added 5 also, and the key for that is going to be 1. What is 1? 1 is going to index at which 5 is appearing in this, okay, in the original array. Next 4, again the same thing. 4 I will introduce because 4 is not present already in my window, so I will add 4 also. Okay, so this is how my mapping is going to look now. Okay, so if you see, the end is also increased. Previously it was 2 and now it became 3. So at this point we have reached the maximum capacity of our window. So that is what it's showing. See, max length k subarray sum. So now it is calculating the sum because the length is k, right? So it's trying to calculate the sum. So the current subarray sum is 10. Okay, and so that is the reason why it will add that to the max, okay, length ke subarray sum also. So this is going to be my answer ultimately. Okay, so currently this will be updated to this. Okay, it was empty initially, so the current value itself will be this value itself will be assigned to this. Okay, so this is going to be my answer basically. Yeah. Next, what I'm going to do, see, since I've reached the max length, okay, so first of all I will capture it there some and add it. I've captured there some. Next, what I'm going to do, I will make space for the next element. How I'm doing that, I will remove this particular one. Okay, so I'm doing the same thing. Okay, removing 1 from index 0 from window to make space for the next element. So how my window will look now, it will look like this: 5 and 4. Okay, what is the next element? Next element is going to be 2. So let us add that. So see, 2 is not present in my window already, right? So I can happily add it. Okay, so 5, 4 and 2, again I have reached a length of k. Okay, so this is going to be the beginning and end of my window, and this is how the mapping is going to look. Okay, so remember one thing: whenever I'm popping element out, okay, it needs to be popped, okay, from the mapping also. If you see here, this particular element got popped. Okay, sorry, yeah, one got popped out. So this particular one is now, if you see, no more present. Okay, the key one is no more present here. Okay, as simple as that. Okay, now I have 5 for 2. I will take their sum. What is the sum? Sum is going to be 11. So see, previous value was 10, right? See, this value was 10. Current, Subarray sum is 11. Okay, so I will update the maximum value to this. Okay, this is going to be my answer at last. So I will update it to 11 at last. Okay, so now since I have reached a length of k, what I have to do? I have to pop the left element. Okay, so since, yeah, removing 5 from index 1. Okay, see, this particular 5 from index 1. Okay, removing 5 from index 1 from window to make space for the next element. Okay, so now my window will look like this for 2. Okay, so I will now get the last next element, which is 9. 9 is not there in my mapping. Okay, that is 9 is not there in my window. So I will add 9 to my window. Okay, so this is going to be the dimensions of my window. Okay, the begin and the end index is this. Okay, so next what I'm going to do, see, this is how the mapping will look like at this position. 9 is present at index 4. So highlight this point because see, now repeated 9s are going to come. Okay, so just remember 9 initially is present at position 4. Fine. So again, since we have reached a length of k, what I'm going to do, I'm going to capture the sum. So the current subarray sum is 15. Since it is bigger than the previous maximum, so I will update my the current maximum to 15. Okay, as simple as that. So I have to remove the first element now, since my window cannot have a new element. So I'm going to remove the element which is to the left. Okay, so 4 is removed. 4 from index 2 is removed. Okay, this particular 4 from index 2 is removed. Okay, for window to make space for the next element. So this is how my window will look now. Okay, now comes the most important part. Now comes the element 9. Okay, this particular 9. So now what will happen? 9 is already there in the window, right? Remove all elements from start of the window till 9 is present. Okay. So if you see, 9 is at the last. So I have to remove all the elements for now. Okay. So first I have to remove 2, then I will be removing 9. Okay, what I have to do? See, remove 2 and then remove 9. Okay. To make space for the this particular 9. Okay. So I have to remove this 2 and then this 9. Okay. So I'm first removing the 2, then I'm removing the 9. Okay. So after that my window will be empty. Okay, so this is how my window will look after that. Okay, so now see, first I remove 2, then I remove 9. Okay, after doing all that, I'm going to insert this particular 9. Okay, I'm going to insert this particular 9. So okay, so this is how it will look after the inserting 9. Previously if you see, 9 was present at index 4, that got removed. Now the current 9, which is at index 5, is present in my window. Okay, so my window will look like this now. Okay, this just this one element is now my window. Okay, previously it was like this. Okay, so I removed everything and only this particular element is there in my window now. Okay, like this. Yeah, like this it will be. Okay, fine. So again, same thing happening. See, now I got the window 9. Yeah, this particular part. Now for the last 9 is coming, so I already have a 9 in my window. Okay, so what I have to do, again I have to remove that also. 9 is already in the window. Remove elements from the start of the window till 9 is present. Okay, so I have to remove the 9 which is in the index 5, and finally I'm inserting the last 9. Okay, which is at index 6. Okay, so if you see, this particular thing is now getting inserted. So this is going to be my last window, but again, since it is not having a proper length, so I cannot be adding this to my answer. So my answer which got last updated is this. Okay, max length case subarray sum is 15. So I will be returning 15, and this is going to be my answer. So if you see, like, yeah, Okay, let me zoom out so that I can show the other test cases. So yeah, like if you see all the test cases I have solved, and this is how it looks. Okay, so for this particular thing again, same thing, case 3. So what will happen is at a time only 1 4 will be there in my window at every see, this is how it initially. Then I have to remove that, and then again add another 4, and remove that again, add another 4. Okay, so the idea is it will never reach a length k. My window will never reach a length k. So that is the reason why we have to return 0. Okay, as simple as that. So if you see the space and time complexity of it, see space, obviously, see, we are going to maintain a window, right? So you can see window is okay logically there. We are just controlling the begin and end, but at least we are having a mapping, right? So let me zoom in so that I can show you. So we are going to have a mapping. So this particular mapping is going to take space. So it is O of n, okay, in terms of space complexity, and in terms of time complexity. See, try to understand. We are basically, what we are doing is we are passing the window only once. Okay, that is, we are passing the num set only once. So the time constant will open, but I understand that we are removing some elements, all those things we are doing. But remember, every element will be inserted either only once and removed only once from the window. Okay, so that is the basic idea. Okay, at max, I'm saying at max only one time it will be inserted and one time it will be removed. Okay, so that is the reason why it will open time complexity. So let us see the code now. So I'm capturing the length of the nums array. I'm creating a dictionary. This is the dictionary in Python. Then I'm creating two variables. Okay, max subarray sum. Okay, and the current subarray sum. Okay, so this is going to be my final answer, and this is going to be the answer for the current subarray. Okay, whenever my window reaches length k, the sum of for that is going to be recorded here. Okay, as simple as that. So I'm going to control my window logically using these two pointers, which is begin and end. Okay, both of them will be 0 at the start. So this is going to be I. What is I? I is going to be the element that I'm going to process next. Okay, so this loop will run till while I is less than n. Okay, that is still I will start from 0 until go to 9 minus 1. Okay, as simple as that. So yeah, so first I'm going to add the new element. Okay, I'm going to add the new element. What I'm going to, I'm just going to check whether the okay, let me do this. Yeah, I'm going to check whether num_saw is already there in my array. Okay, if it is already there in my array, what I have to do, it's in here. Okay, let us not go to that because we are going to try the code the first time. So let us go with the first. What will happen is initially this condition will not be possible, so this condition will be executed. So what will happen? See, I'm going to take I is going to be index. Remember that I is index. Okay, I is not the value. Num_saw is the value. Okay, so I is going to be the index. I will be recording I as the value for index nums of I. Okay, that is, you see here for 5, that is 5 will be the key and the value will be 2. 2 is the index of 5. Okay, so similarly I will append that. Okay, that is, I will make an entry in my dictionary. Then I will increase my end because a new element got inserted to my window, so end will be increased. Then what I'm going to do, I'm record the sum of that. Okay, sum subarray sum is equal to subarray sum plus nums of I. Okay, the current element I'm going to add. Okay, in my sum. Fine. Then what I'm going to do, I'm just printing these things for your easiness. But while Samudra should remove all the print, otherwise output limit exceeded error will come. Okay. So what I'm going to check after I insert every element, what I'm checking is whether I reach the length of k. Okay. Only if I reach the length of k, this part will be executed. Okay. Otherwise, what will happen? Simply as you I plus 1 will happen. I will go to the next value. Okay. So here, let us see this part first. If I reached a place where the window length is k, what will happen? First of all, I will capture the sum of that. Okay, subarray sum will be having the sum of the current elements of the window. I will compare that with the previous maximum, and whichever is the maximum I will record it in my maximum. Okay, that is fine. What I'm going to do next, I have, since I've reached the end of my window, that is, I cannot expand my window further, so I will have to make space for the next element. Okay, so I have to remove the element towards the left. Okay, so what I'm going to do, I'm going to move my begin. Okay, so whichever element is that in my begin, that will be removed now. Okay, so I will remove that from the subarray sum. Okay, then I will pop that out from the mapping also, and then I'm going to begin is equal to begin plus 1. Okay, then I'm done with this. So this is the process that will follow whenever we reach a window of length k. Okay, other than that, now let us come to this. Let us say we already have element in my window that is coming for the second time. What we have to do, we have to remove all the elements, okay, before that, until we remove that element. Okay, the idea here is, for example, see, for example, let us say my window is like this, 2 4, okay, 2 4 and 9. Okay, this is my window currently. Okay, now 4 2 and 9. Okay, whatever it is. Okay, it is, just a second, it is 4 comma 2 comma 9. Okay, so we are having like this. Okay, this is my window currently. Okay, let me zoom in. So what will happen is, now the next 9 is coming. So what will happen for the previous 9 and all the elements before it, everything should be removed now. Okay, so see, removal always happen from left to right. Okay, so first 4 will remove, then 2 will remove, and then 9. So the idea is, till this 9 is present, I cannot insert the next 9. Okay, so till this 9 is removed, I have to keep deleting the array. Okay, that is what I'm going to do here basically. Okay, so if you see here, that's what I'm doing. So till begin is less than a of nums of I. Okay, that is I'm checking at which index the nums of I is already present. Okay, remember nums of I is already present and it's coming to for the second time. So I'm checking at which index it is already present. Till then I'm going to remove all the elements. So what I'm going to do, subtract that element from the C. Remember this is the begin. Remember this is a begin, not the element which will be inserted. Okay, it's a begin. Okay, so remove the beginning element from my subarray sum, pop the element from my mapping for the begin element, and then do a begin plus one. Okay, till you have to do this till the element, okay, which is repeating is not removed from the window. Only after that is removed, I will be inserting that again. Okay, this is the part on which we'll be inserting that element again. Okay, so as similar as that. Okay, this is the part. So this will be done, and at last, see, this will be done till the previous elements of the nums is removed, and after that, we'll remove the nums itself. Okay, this is the part for that. Okay, and after that, the element will be reinserted, and then we'll check whether we have reached a length k or not. If we have reached a length k, we will be again checking, well, calculating the sum. That sum will be comparing with the max sum, and then we are removing the last element. That is the left element from it again to make sure for the next element. This will be done, and finally we'll remove the return the sum. So let me quickly run this again, show you. So while submitting, you have to just remove the output statements. So if you see it's creating all that description, I've already submitted this. Okay, this is O of n space complexity and O of n time complexity. So yeah, and that was all for today. This was slightly longer video, but I hope you understood everything, because see, I have given you from the scratch. I'm giving the solution to you. Okay, so like everything I've covered in this video. If you like find any issues, you can let me know. We can discuss it further. But let me tell you this: this is going to be a very very important question. This is the exact level for which you can expect questions and face-to-face interview. So often that was all for today. If you like my efforts, please do subscribe to my channel. It takes a lot of time to make this kind of videos, because see, I'm trying to simplify the to the to the most basic level possible, so that even someone who is just coming to college and learning coding, they can also understand this. Okay, so my aim is to make the coding very much easy for everyone, so that everyone can you know get benefit from it. Okay, so often that was all for today. See you tomorrow. If you like my efforts, please subscribe to my channel. Just a reminder once again. Thanks a lot.